A single gram cost more than gold. For 3,000 years, nobody outside Phoenicia knew how they made it. Scientists just cracked the code, and the answer involves rotting sea creatures, precise timing, and a chemical reaction the ancients discovered 2 millennia before modern chemistry existed. Here is what kept historians puzzled for centuries. The Phoenicians dominated Mediterranean trade from roughly 1500 BCE to 300 BCE. They invented the alphabet you are reading right now. They sailed beyond the Pillars of Hercules. But their most jealously guarded secret was not navigation or writing. It was color. Specifically, one color. They called it argamon. The Greeks called it porphyr. We call it Tyrian purple. Ancient records describe it as the color of clotted blood that shimmered red in one light and violet in another. Roman emperors made wearing it punishable by death for commoners. But here is the mystery that nobody could solve. Ancient texts mention sea snails. They mentioned processing facilities. They mentioned unbearable smells. What they never mentioned was the exact process. How did you turn a living creature into the most valuable substance on Earth? The answer starts with what archaeologists found buried along the Lebanese coast. Mountains of shells. And I mean mountains. At the ancient site of Sarepta, excavators discovered shell deposits over 100 feet long and 3 feet deep. These were not food waste. Every single shell was cracked in exactly the same place. A precise hole punched through the same spot on thousands upon thousands of Murex brandaris and Murex trunculus snails. Someone was harvesting something specific from inside these creatures. The Phoenicians built entire industrial complexes dedicated to processing these shells. And the smell, according to ancient writers, was so horrific that dye works were legally required to operate downwind from cities. If you think that is bad, wait until you hear what the process actually involved. Because what researchers discovered explains not just the smell but why this color was genuinely irreplaceable. Now pay attention because this is where it gets genuinely remarkable. Inside each Murex snail sits a tiny gland called the hypobranchial gland. It produces a mucus the snail uses for defense and egg protection. This mucus is initially yellowish-white. Completely unremarkable. But when exposed to sunlight and air in a very specific sequence, it undergoes one of the most complex natural chemical transformations ever documented. The compound is called 6,6-dibromoindigo. And here is what makes it special. Most organic dyes fade in sunlight. Tyrian purple does the exact opposite. It becomes more vibrant, more saturated, more valuable. The Phoenicians somehow discovered that if you extracted this mucus at precisely the right moment, let it ferment in precisely the right conditions, and exposed it to light in precisely the right sequence, you got a color that literally improved with age and sun exposure. But knowing the chemistry is one thing. Actually producing dye at commercial scale, that required something approaching industrial genius. Marine biologist John Edmund spent years trying to recreate authentic Tyrian purple using ancient methods. His research revealed the staggering scale of Phoenician operations. To dye 1 pound of wool required approximately 12,000 snails. A single royal garment might need 250,000 individual creatures. The Phoenicians were not running small workshops. They were operating what can only be described as ancient factories. Workers would collect snails by the tens of thousands, crack each shell at the precise point, remove the gland within 3 days of capture before the creature died, then pool the glands in massive fermentation vats. The mixture had to putrefy for 10 days. In Mediterranean summer heat. Think about that for a second. But here is where the story takes an unexpected turn. Everything I just told you, that is just the raw materials. The actual secret. The part that made Phoenician purple different from every imitation, came down to something nobody understood until 1998. A chemist named Patrick McGovern analyzed ancient dye residue from a Bronze Age site. What he found changed everything. The Phoenicians were not just fermenting snail glands. They were precisely controlling a bacterial fermentation process. The specific bacteria, the exact temperature, the timing of sun exposure, all of it affected the final molecular structure of the dye. Get it wrong and you got a muddy brownish purple. Get it right and you got the legendary color that made empires tremble. And this is where it gets really interesting. Different Phoenician cities produced slightly different shades. Tyre's purple was different from Sidon's purple. They were essentially running competing chemical operations with secret proprietary processes. Ancient industrial espionage was absolutely a thing. Now think about what this means. The Phoenicians, working roughly 3,000 years ago, had developed what amounts to a controlled biochemical process. They understood, at least practically, that specific conditions produced specific results. They knew timing mattered. Temperature mattered. Exposure mattered. They were doing chemistry without calling it chemistry. But here is the part that genuinely surprised researchers. When they finally analyzed the dye's molecular structure, they discovered something remarkable about why it was so color-fast. The bromine atoms in the molecule create an incredibly stable bond with wool and linen fibers. This was not just a surface coating. The dye literally integrated into the fabric at a molecular level. Ancient Phoenician textiles recovered from archaeological sites still show vibrant purple after nearly 3,000 years. No other ancient dye comes close to that kind of longevity. The color was not just expensive. It was practically eternal. So now we can finally answer the question. How did the Phoenicians actually make Tyrian purple? Step 1. Harvest murex snails within 3 days of capture, crack the shell at the fourth whorl, extract the hypobranchial gland. Step 2. Combine glands from multiple species in specific ratios. Murex trunculus produced a bluer shade. Murex brandaris produced redder tones. Master dyers blended them for desired hues. Step 3. Salt the mixture and let it ferment in covered vats for exactly 10 days. The bacterial action transforms precursor compounds into dye molecules. Step 4. Add aged urine or wood ash to create an alkaline reduction bath. This makes the dye soluble. Step 5. Submerge fabric and expose to air gradually. The oxidation reaction turns the yellowish solution purple. Step 6. Expose finished fabric to direct sunlight for days. This finalizes the molecular structure and deepens the color. Each step required precise timing. Each step required generations of accumulated knowledge. The Phoenicians guarded this process for over 1,000 years. When Alexander the Great conquered Tyre in 332 BCE, his soldiers found royal storehouses containing purple worth approximately $285,000 in today's money. When the Byzantine Empire fell in 1453 CE, the secret finally died. The last master dyers took their knowledge to their graves. It took modern chemistry and dedicated researchers nearly 500 years to reconstruct what ancient craftsmen once knew by heart. And here is what makes this story genuinely remarkable. These were not scientists with laboratories and spectrometers. They were traders and craftsmen who developed a sophisticated biochemical process through centuries of trial and error. They understood color chemistry at a practical level that rivals our theoretical understanding today. The next time you see purple fabric, remember. For most of human history, that color was quite literally worth killing for. But wait. There is one more piece to this puzzle that most historians overlook. The Phoenicians did not just sell purple. They sold status. They understood something fundamental about human psychology. Scarcity creates desire. Difficulty creates value. They could have expanded production. They could have farmed snails. They deliberately chose not to. By keeping supply limited and prices astronomical, they ensured that Tyrian purple remained the ultimate symbol of power and wealth. Roman sumptuary laws restricting who could wear purple. The Phoenicians loved that. It maintained exclusivity. It maintained price. It maintained their monopoly. They were not just ancient chemists. They were master marketers manipulating supply chains and consumer psychology 30 centuries before business schools existed. The science of creating purple was remarkable. But the business of selling it? That might be their most impressive achievement. Today, you can buy synthetic dibromo indigo for about $300 per kilogram. The molecule is identical to ancient Tyrian purple. But something has been lost. When researchers recreate the authentic ancient process, using real murex snails, real fermentation, real sunlight exposure, they discover subtle variations that synthetic versions cannot replicate. Trace compounds from the bacterial fermentation. Microscopic differences in molecular orientation. The ancient method produces something measurably different. And perhaps that is the final